am Batel from Solar PV, a fresh startup company develops indoor photovoltaics. You all probably know that today the best way to power wireless devices is batteries, but these batteries result in a disposal of over 50 million batteries a day. Do you realize the impact of this number? High carbon footprint, economic implications, maintenance burden, and now also new strict regulations adopted by Europe. Do you recognize these buildings? Sorry, these buildings? The buildings we are now in, Turmei Rubinstein. These buildings have more than 8,000 rooms and most probably more than 25,000 sensors. Considering those sensors are powered by batteries, that means more than 250,000 batteries replacement during the sensor's lifetime. Now, think about all the other buildings around us. Don't you think we need a better solution? This solution is indoor photovoltaics, IPV. IPV are small devices that capture ambient light and convert it into electricity. That means we can reuse the energy of light already existing in the room and reduce the use of alkaline batteries. This solution is green and efficient. And we are not the only one that think that. By 2027, the regulations on non-rechargeable batteries will be more strict, and we can see that big companies like Google and Amazon already started to invest this solution in the recent years. However, the current IPV technologies available in the market today have limitations, and this is exactly where Solar PV steps in. Solar develops an innovative perovskite-based indoor photovoltaics. These solar panels are cost-effective, recyclable, and have a great potential efficiency, overcoming the 40% under indoor light. Solar utilized a unique cell structure based on layer-by-layer printing of mesoporous metal oxides. The perovskite is penetrating in between those layers and yielding an efficient energy conversion device. Looking on competitors with different IPV technologies, such as silicon, OPV, or even other perovskite architecture, we can see that solar generates more power for the same panel size. Here you can see a short video of wireless environmental sensor powered by solar PV panel. The sensor is monitoring the humidity and temperature in the environment, and the information is transmitting to the phone. The market size is $57 billion, and it can be split into two main categories, IoTs and consumer electronics. We are now focusing in the energy efficiency area and collaborating to test our solar panel into hotel rooms. Our business model is B2B, starting by selling PV panels for OEM, and later on, when it comes to mass production, also licensing the technology. We started our activity 1.5 years ago, and now we are stepping into the seed stage, looking for investment in the amount of $1.5 million. Our team, including Professor Lior Etgar from the Hebrew University, Dr. Yosef Faraj, and myself, Dr. Batel Cohen-Wiesel, all with wide expertise in photovoltaics, perovskite, and printing technologies. So come and join us to strive for energy sustainability in our everyday environment. Thank you.
So, this is new this year that we haven't done previously in the other 3 years. Mic back, because we're leaving room for our jury to ask questions. Sean has a mic right now that he can pass to any of the jury to ask a question.
Hi, I'm Jared Bierbach with the U.S. Department of Energy. Thank you so much for that great pitch. Just curious, I'm always interested in partnerships. Do you have any strategic partnerships, and how do they enhance your business?
Yes, so hi, Jared. So we are now starting to collaborate with Rotal Group. Rotal is a company, they're doing electronics and ITO devices. So we want basically to take our solar panels, the indoor solar panels, and to pair it with the electronics we needed for. Currently, we are talking about hotel rooms, as I said. So you have the door locks in the hotel. So for this application, and to test this in individual in hotel rooms in stuff like that.
Thank you.
Welcome.
Hi.
Hi.
Should I press something? It's working? Sorry. Hi, I'm Maria from Tehran, and I have a question about the perovskite. The reason why you decided to go to perovskite, because you don't use the transparency of the layer, as far as I see, and what is the ROI of the system? Thank you.
Okay, so perovskite is a very unique structure. It's not only using for transmittent photovoltaics. One of its best its unique properties that you can change its band gap. You can tune the band gap according to your wishes. So why the perovskite solar cells are better for indoor than the silicon? Because the spectrum of the LEDs and fluorescents is different than the spectrum of the sun. For the sun, we need an absorber in the band gap around 1.3 electron volt. But for LEDs, we need 1.7, 1.8 electron volt. So the silicon, you cannot change its properties, you cannot change its band gap, but the perovskite, I can change its band gap in the lab. I can use other components and to tune the band gap to be 1.7, 1.8, and in that way to get energy efficiency, better energy efficiency from the LEDs.